Oh, what a sad ending to the music that we've all heard for 4 weeks. Hello, how are we going? Stream check. Look what I did. Can you see this? I have a stream deck on my phone, so now I can do this. Whoa. Whoa, that's high quality production that you won't get anywhere else. Um, Mic check is good. You can't see the slides now. You can just see me. But now you can see the slides. That's technology. Cool. Mic is okay. The volume is okay. Is it a bit quiet? I think I can put it up a little bit. Hello, hello, hello. Is that better? I don't know if that did anything. All right. Does COMP1511 have a different assignment to 1511? No, not for assignment 1. It's exactly the same. And I think you're all blessed by the assignment author in this chat. So if you've got any questions, you know who to ask, Brianna. And we are very grateful for Brianna's hard work. Alrighty. Assignment 2, there's no difference, but I think there's a slight difference in the amount you need to do. So there might be some 1511 specific stages that you don't have to do for assignment 2. But let's not worry about assignment 2 just yet. Put this here. All right. How are we all feeling? So week 4, I noticed the energy in the lectures go down. Everyone's a bit tired. Not me. I'm feeling great, which is good. I think you start getting your maths assignments due and all things like that. How are we feeling? It's more difficult for sure, and that's not really going to change. I wish we had the music going still. Yeah, good. Okay, are we ready to get going? Oh, we have a cute little poll. All right, while you do the poll, let's talk about a few things. Sorry, I look to the left, right, because I'm looking at the lecture chat, but maybe I'm going to move it here. Okay, so, as who was saying it before? Was it Ben? Yeah, Ben was saying he got his tickets to the week 5 lab exam. How exciting. You can get your tickets. In fact, you must get your ticket at this link. I imagine Bree or John is going to put it in the chat. There it is right there. Too good. There's the code COMP1511. Sorry, 1911 students. You just use that code. We still love you. So why are we doing this? This is new this term. So as you all know, at the end of the term, you have an invigilated final exam that's worth a significant component of your final marks. And it's also a hurdle exam. There's some hurdle questions. The exam has a unique format and structure. And what we've noticed in the last few years is that a number of students get a bit freaked out by the exam. So what we're doing is having a mini practice exam in the week 5 lab. So that's next week. So all you do, you don't have to do anything special. You go to your week 5 lab like normal, ideally in person. Well, you really must go in person to get the full experience. And then during the lab, during that 1 hour tute, you do a practice exam with a limited number of questions on content that you've already studied. And you use the same environment that you'll use in the final exam. So it's really important to get used to the structure. Now, it's worth 1 mark. Okay, so this isn't like a fully assessed exam. It's to get you familiar with the structure. And that's really, really important. It's just good practice, okay? Because no matter what people say, they do these practice exams and these practice questions, but it's not the same as you're in person. Okay, so there's a few questions. What's the email if I can't attend? Okay, Leon, I really, 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 really urge you to attend an in-person tutorial. If you're in a online tutorial, there's just a few of you. We have a different process for sending you to an in-person tutorial just for week 5. If you really can't make it, you email cs1511@unsw.edu.au, but you really need to have a good reason to not do it. So do you need to get a ticket if you have a normal in-person exam. Do you mean you have a normal in-person lab? Then no, you don't. This is only for online tutorial students, I believe. Bree's going to double check me on that. Yeah, that's right. So no, you don't need to do it. You just go to your normal lab as usual. So this is only for tutorial students, online tutorial students. It's only worth 1 mark. It's not about the mark. It's about the practice and the environment. Okay. Any questions on that? Go look at the, I can do this. Maybe. Bang. Can I do this? Go look at the forum. Did that work? Oh my God, that didn't work. Chrome. I didn't hook that up right, I guess. Go look at the forum. There should be an announcement. Maybe not yet because we just released the assignment. So we'll work on that. Okay, full cam. We'll go back here. Actually, we'll go back to slides. No, every single person has to do the practice exam. No, and there's no hurdle. And the week 5 practice exam is separate from the week 5 labs. That's correct. It takes place in that first hour of the tutorial. Is there a ticket to the lab exam on the website? You just use the ticket link on the slide right now, or that Bree put in the chat. I'll get an announcement on the forum with the consolidated details. I think that would be good. Okay, I guess this wasn't clear. Don't worry about it. If you've got an in-person lab, go. If you don't, you need a ticket to reschedule. I don't know about changing it. We got to move on. Just email the course account. Sorry. I have 2 labs? What? You shouldn't have 2 labs. We're talking about the tutorial. So you do this in your tutorial. No one's got 2 labs, as far as I'm aware. All right, we made it ready to move on. If you got any questions, you just email CS1511. Okay. All right, so let's do a quick recap of strings, a really quick one. Strings are arrays. An array is a variable that points to a piece of memory. Strings are arrays of characters, and anything we can do with arrays, we can do with strings. They are arrays. There's no difference. This is a character array, with the caveat that we put the null terminating character at the end of the array so that we signal to the program, to the operating system, to the computer, to our other programmers, that this is the end of the value that I want in my string. The reason we do this is because if I want to or need to reassign different values to a string variable, I need enough room in the array to fit potentially longer strings. So what we do is we make our string arrays, character arrays, bigger than we think we need them to be, and then we just put the null terminating character in the position in which we want our string to end. Here's like a little cheat sheet slide with a bunch of information. So we have string literals. These use double quotes to wrap around a sequence of characters that we can do things like assign to strings when we create them, or you can pass it to something like string copy to reassign a string. So this is how we represent strings in code. And so, yeah, you can do something like this. Car name equals Jake Renzella, and that's the string literal value being assigned and initialized to the character array name. And then we have a whole bunch of useful string functions. If you want a in-depth demo and recap of these functions, you have a look at yesterday's lecture where we did basically a demo for all of the important string functions, which was really nice. Some really, really useful ones that you must know. fgets, fputs, string length, string copy. Yeah. Maybe, and string compare, maybe. The other two are less important. And of course, you need to note that these come from the string.h header library. Cool. Are there any questions on strings? I'm going to assume no, wait for the delay. Okay. Whale has asked, what's the advantage of fputs versus printf? Okay, I'm going to answer it quickly and let Bree or John put the longer answer in, but essentially you can print a string with the %s character. My understanding is that there are potential security concerns over doing that. So there are vulnerabilities with printfing certain types of strings. And fputs is a more robust solution for printing strings in C. So we just suggest that we get into the habit of using it. C is one of these languages with lots and lots and lots of security vulnerabilities if you don't really know what you're doing. This is exactly what happened with CrowdStrike a year or two ago. Was it a year ago? Yeah, maybe about a year ago now, where they had a significant memory vulnerability that caused a huge problem. So what we're just trying to do is teach you good practice and to fputs a string. Maybe Bree or someone can find a nice little article online for that information. But good question, good to question it. Yeah. Oh my God. Okay, back to the exam question. How do we get the 1 mark from our lab exam? Yeah, you just have to do the... you have to attempt the exam. We're not marking it. We just want to know that you rocked up and went through the process. Cool. All right. Yeah, this is really important. You can't reassign a string the way you would kind of like to. So, whoops. We can't do this. This does not work. Why doesn't this work? Because strings are arrays and we can't do this to an array. So instead we have to do this. So if you come up with some string variable, you give it some max length so it can store a bunch of characters, and I assign it the string literal Jake. This will be Jake, null terminating character. If I want to reassign it something like Mr. Otterington, I don't remember what that was a reference to, you need to use the string copy function. That's why the string copy function is one of those really important functions. So it's literally how we reassign strings. Really useful. And John's got a nice little explanation in the whoa, I didn't want to do that. Go away. Okay, great. All right, Zootopia? Don't know. Okay. New topics. Sort of new topics. They're not really new topics. They're just new ways to use the tools we already have. We have a question. Does it make another string with the same name? So there are 2 strings with the name. No. Okay, that's a good question, Snuggo. I don't know if that's your real name. I apologize. I probably butchered it. It's not copying the variable. So string copy does not mean copy this name variable into a new piece of memory. It copies the value of this string or whatever string is on the right. So it might be the string literal, or it could be another variable that contains a different string. And it copies it into the string variable on the left. So it's not modifying memory. It's not copying a memory allocation. I can see why you might think it could do that because of the name copy, and sometimes we have like functions like memcopy that do that, but in this case it's just copying the string value, so no new memory allocation occurs here. So that's a very good pickup. Yeah. All right. There is a bit of a stream delay, so if there are any more string questions, let me know. I'm going to give it a few seconds and then we're going to move on to today's content. Actually, I'm just thinking about your comment again. another way to think of it is that you can't have two variables with the same name. So that's another clue to you that this could never do a memory manipulation, right? You can never ever have within the same function scope, of course. So this is all within the same function scope. You can never have two variables with the same name. That would be a compiler error. It'd be a compiler error. So that's another clue that this was not manipulating memory. But yeah, I like that question. Okay, let's get going. Arrays of structs, a conceptual introduction. So let's just look at structs again. Structs allow us to store groups of disparate data. So what do I mean by this? I mean that this is not homogeneous. Okay, so remember arrays were homogeneous. We always store the same types of data. Structs lets us group different types of data, maybe the same type of data, it doesn't matter, into a model. So I could have a student struct that contains a student's name. That could be a string. Wow, we can do that now because we have strings. So I can actually store a name. If you remember back when we did structs and the student struct in the past, we did an initial because we only had characters at that point. So you can see we're starting to get way more capable with what we're able to do. We define structs above main, right? So we describe what the particular struct data types might look like, and we can use them in a particular program. And we use the dot operator to access a particular field of a struct. And I think we'll do a quick demo of this once we get to what we're trying to talk about today. Okay, so everyone remembers what structs were. You make one with like struct, student, curly bracket, and then do like wham, name, whatever you want to do. So that's the struct. And of course, we know we have arrays. We've been talking about these more recently. We create arrays to store multiples of data, and they're homogeneous, so we can only store a particular type of data. And so we can put any type within that structure. So it could be a character, it could be an int, and it could be a struct. And this is sort of what we're talking about right now. So can we have an array of structs? And the answer is absolutely yes. You can, and it's a very, very, very useful and important pattern or something that we want to do. So here's a little diagram to visualize what's happening here. So in this case, I'm creating an array called students, and the data type of that array is, for example, struct student or whatever student struct. And we'll jump into code and look at this in a minute. We have a sequence of elements. Oh, that should be a 2. Forgive me. That's the index, 0, 1, 2. And in each element, we see the fields of that struct. So in this case, I've got another array. Well, I got a string, and I've got an age. So name, age, name, age, name, age. And so I use it exactly how you would expect to be able to use it. So I say students indexed at the index 1, and then I can say use the dot operator because it's a struct and get its particular field. So in this case, name. So why don't we jump to code? Look at that. That was smooth. Let's do array of struct.c. Okay. We do hash include standard.io.h int main void return 0. I might make that a bit bigger. How's that? Now I know I saw some feedback that when I do the lecture demos, it's a bit fast. The problem is if I slow it down too much, we won't get through enough in the lecture. So what I suggest, if the demos are too fast, that's not a commentary on you being too slow. It's just we have a lot to talk about in the lectures. So all I suggest is that you sort of pay attention to the demo, and maybe if you want to follow it along, you can just re-watch the YouTube video and then you can pause it and do what you need to there. Cool. All right, what are we doing here? So first thing we do is we need a struct. So let's remember how to write a struct. So why don't we do this student example? Let's just do struct student record. Okay, don't forget our semicolon. Here we could have the age of the student. We might have the double wham of the student. I'm not going to put in a name here because I don't want to get it too complicated. That's enough for now. Absences. Yeah, maybe we could like count their absences. That's a good idea. Cool. So it doesn't matter. I could put a bunch of things in here, whatever I want to put in. So I got this student record struct. Do we want to recap how to just make a single struct? We can just do struct student record, student underscore 1. That will create a single student record named student 1. Then I can say student 1 dot age equals 25. Now, is there something wrong with what's going on here, or is my autocomplete just really slow? I think my autocomplete is really slow over SSH. So I'm going to assume that's okay. We got our WAM. I don't know, what's our WAMs out of 80. And we got absences. And maybe this is a really good student who hasn't missed any absences. All right. What I'm going to do now, well, first I'm actually going to check that this compiles. So DCC array of struct dash out to program. Okay, what have I done here? Okay, so it's just warning me that I've set some values in my student1 struct, but I'm not actually using it. So that's pretty fine for now. That's what I've expected. I run program and I don't get an error, so that's fantastic. All right, what I'm going to do now is make a procedure called print student that accepts a struct student record, and then call it student to print. And its job is just to print the student, so we can just do printf, printing a student. We can say student is %d years old, comma, then we go student to print dot age. Student has a %lf WAM, right? LF because it's a long floating point. And the student was absent %d times. No absences. Okay. Then we might just go printf \n. Whoops. All right. So I've made a procedure to print out my student record to the terminal. That's really useful because it means once I create one, I can just say print student underscore 1. And if that works fine, what we should see when I open up my terminal, I recompile that program. I get that data printed out, which is fantastic. So that's really good. So that's just setting up a struct. What I really want to do is have an array of students because there's many of you, right? So instead of creating a single struct, I can create an array of struct and array of structs. And the way I do that I might just lower this by 1, if that's okay. Let me know if you can still read that. So array of structs. Okay, let's think about this. If I make an array, it's type, name, size, right? So what's the type? And I want you guys to tell me, what's the type of this array? And there's a lecture delay, so I need to wait a second for everyone to hear me and tell me what I want to know. It's not just struct. It's not just struct, although that is the first thing I type. Paints is even closer, but it's the wrong way around and it's not complete. Struct student record. Yeah, that's exactly right. MMC comes in first with the exact thing I need to type. But you've all got the right idea. It's a struct student record. Why struct student record? Because that is the type of my struct. So that's its type. Then we need its name. I'm then just going to call it students. And then what makes it an array is, well, we need the size. Now, size doesn't mean anything just yet, so we can just hash define. Size can be, let's say 5. So down here, size will go like that, and we can put a semicolon there. Did I put a semicolon? That was dumb. That's always remember to not put a semicolon after your hash define. I do that all the time sometimes. So struct student record size. And if we're good citizens, we should probably zero it all out using that syntax that we've spoken about many times. I might just comment out that single student example for you. All right. So that means none of this is going to make sense, but for now, that's fine. So we have this array of 5 elements. Let's actually just make it 3 to make life simpler. Of 3 elements, what do we need to do? Well, when we have any array of data and we need to manipulate the data, we need to use a loop. All right? So I can say int I equals 0, while I is less than size. We know because that's how many elements are in the array. And we can put some data in the array. Now, this is how we access the struct once we have it, but we don't have a struct, we have an array of structs. So what's the name of our array and how do we get to the particular struct in each index? What do you think we need to do? Oops, sorry if you can hear me drinking. Students of I. You guys are too good. All right, very good. Students is the name of our array. I is the index. And then once I've accessed the particular index of an array, I get a struct, and then I can go ahead and fill it out. Look at that. Beautiful. Absolutely beautiful. Whoops. So now it's just going to set every student to be the same age when I'm in absences, but that's fine for now, I think. All right. That's loading up the array of structs with some data. Let's look at printing it. So we restart our loop. And this is where having a helper function is really great because now I just say print student. Is that what I called it? Yep. Students of I. Semicolon. Do you see that? So we loop through every element in the array. We access the particular struct in the array index and we pass it to the print function. So we pass each individual struct value to the print function. So if I recompile this program, and I haven't made an error, which I haven't, I run this. Looks like have made some sort of error. Oh, what did I do wrong, guys? You guys can tell me. You fool, Jake, you fool, you fool. Yeah, I just forgot to add 1 to I. We need to do that here, and we need to do that here, and we reset I back to 0 here. So I was just never actually running the loop. Classic mistake. Cool. So what we get out in the terminal, and I'm going to just make it bigger, is these 3 student structs, all stored within an array. How cool is that? This could also be a function that returns, that scans in the values. So that could just be a 1-line function. And we just have a really nice way to work with arrays of structs. So this is really, really useful. all the time, to be honest. It's just really useful. Do we have any questions on arrays of structs? I know that was a pretty quick introduction, but there's a lot more to get through today. Jake is a great lecturer. He deserves, like, you all deserve arrays. Arrays are great, and they're used all the time. It's one of the most common data structures. Where does student to print come from? Student to print. So that's up here in the print student function that I created. So basically what I wanted was a function so that I didn't need these 4 or 5 lines of code every time the function ran. And student to print comes from the parameter to the function. So what I'm saying is that the data that's going to be passed into print student is going to be a struct student record. So that's the type. And it's going to be called student to print. So I just created this. I named this variable as the parameter name. Does that answer your question? And the value comes from here. I'm passing in each index of the array, which is a student struct, because it's an array of 3 student structs. Good question. Mine just isn't working for some reason. The best thing to do if you can't get it working is to open the lecture code. Bree's going to resend the link, and just you can compare line by line. But don't get too stuck on doing that now. Just make sure you understand the concepts of what we're talking about. All right. Final opportunity for any last questions on this stuff. Maybe a good little extension activity for you after is to add a string here, student's name. That would be really cool. If we get time at the end, which we probably won't, we could do that. All right, am I good to continue? If you want to rename a struct in the array, do you use string copy? So no, that's not struct copy, that's string copy. Don't get them confused. If you want to rename a struct, I mean, you don't have... What do you mean by rename a struct? Because there's nothing really here to rename. If you had a string in here, you know, like something like that, then you would use string copy to reassign it. So that's on the right track. But without it, like what we had today, we have nothing to use string copy on. Remember, it's string copy, not struct copy or anything like that. God, this is a sensitive mic. I can see it bouncing. Anyway. Limes, if you've got more questions, please do follow up with it. All right. Shall we continue? What do I do here? I hit slides. Cool. Okay. So that's one application of arrays of structs. Remember, we can store basically any data type we want in an array. And what that also means that we can do is store, and you got to bear with me, right? You can store another array in each element of an array. So you can have arrays of arrays. Okay, so for every element in the array, you have an array. This is called a two-dimensional array. The best way to do this is to, and damn, that one doesn't work, to draw it out. So, wrong Chrome. Let's go to Microsoft Whiteboard, which is what I like to use. You can't see, no, yes you can. Sign in. Really nice slow loading thing here. Really lovely. Thank you, Microsoft. We all appreciate you. I don't know what that is. Okay. What is this? I just want a whiteboard. What is that? I just want a whiteboard. Okay. Where's my pen? All right. Okay, this is a bit tough. Let's move this around. All right, so if I've got my array, it's got a bunch of elements, doesn't matter how many, and we always index our arrays with the indices because it helps us understand how to refer to them. And we can put any type. I know, what great handwriting. We can put any type we want inside of our arrays. So this could be an integer, this could be a character, that would be a string, this could be a struct. And the other thing we can do is put in them an array. And so what that gives us, the way I like to visualize this is a second array. I know what you're thinking. This guy needs a graphic design career. And let's say I've got an array of integers, like that could just be some integers here. And that would obviously be so on and so forth for the rest of the array. Now, why are two-dimensional arrays useful? Okay, two-dimensional arrays are useful in many, many circumstances. Circumstance number one that they're useful is you have a two-dimensional structure that you're trying to represent in a data structure. Okay, what the hell do I mean by that? A chessboard is another good example. A chessboard is very typically represented as a two-dimensional array. You have an array of tiles of an array of tiles. That gives you a two-dimensional array of tiles. You can imagine if I fill this out, right? Like so. What I have here is something that looks like the representation of a chessboard, right? A 2D grid. Any grid-like data structure you use 2D arrays for. So we can say grids. Really useful. So that's something like chess, any board game like that. Any tiled video games or anything with tiles, like The Sims. I know lots of people still play The Sims. You could imagine the game world as like a two-dimensional grid of tiles, for example. They're also useful for something like matrices. Matrices are two-dimensional grids of vectors or whatever you might want to have in them. Right? So very, very useful all the time. So you always have an array of an array of a type. And in that sense, nothing's changed. They are still homogeneous. I'm going to misspell it. I always misspell that word, and I don't want to stop it. Homogeneous, and that can't be right. Okay, no, that was fine. They are still homogeneous. There's always one type in the two-dimensional grid. Alrighty. Oh, that's not what I wanted to, but anyway. Let me look at the lecture chat a little bit here. Will we need two-dimensional arrays in the assignment? In assignment 1, I believe you will. Bree might need to comment. Each element of the array has enough space to hold a small array, so yes, this is a nested array. Yeah, absolutely. They're nested arrays. That's another way to think of it. Yes, of course, yeah. And yes, you will need two-dimensional arrays in the assignment, but probably in the later stages. Okay. For I from 0 to n. Okay, no, you're talking about loops, so we'll talk about later. I say thanks. Jake was saying the other day, arrays and loops are best friends. Yeah. Okay, we'll talk about how we actually create them and loop through them later. Okay, cool. Okay, do we get the concept of, I should end this poll. Do we get the concept of what we're talking about here? So we have an array of a data type. It's pretty simple. Conceptually, it's simple. I think in implementation, it's not that simple. It can get a bit confusing. Great. Good. That means we shall jump into a bit of a demo, I think. Let's go back to slides. Okay, so we need to look at the syntax for creating a two-dimensional array. And the way we do this is kind of not very different from what you'd expect, I imagine. So we give it the data type. So this is the data type that will be stored in the nested arrays. So within, you've got your top level array. Within that array, you have a sequence of arrays. In the elements of those subarrays, this is the data type that you will store. And in this sense, two-dimensional arrays are still homogeneous. So this would be int, char, double, a struct, whatever it is you want. I'm going to put the mic down. I think you can hear the construction. Okay, that looks better. Okay, then you give it the identifier. This is just the name of the two-dimensional array, the variable name. Then you go square bracket, like we always did with the size, except this is the size of the rows, and then we give it the size of the cols. Something that always happens is that you get these two confused. That's completely fine. You'll learn about it, and I'll teach you some strategies for figuring it out and reasoning it now. Let's just look at some syntax. Okay, this is great. Int my grid. So I have a two-dimensional array named my grid. Its data type is integers. So this is going to be an array of integers. This is a square grid. So it's going to be 5 rows and 5 columns. All right. If I then access, this is using my grid, 2, then 3. It's 0, 1, 2. 0, 1, 2, 3. So we get this element here. All right. Let's jump into VS Code and get going with this. 2D array intro.c. All right. How about I'll take this demo a bit slower? He says as he copies and pastes a whole bunch of code. We don't need that. We don't need that. All right. I'll give people a second to catch up here. While I do that, let's define what we want to do with this program. A program which creates a 2D array, assigns values to each element, prints out the 2D array to visualize how it stores data. All right, so this is just going to be a very light introductory program for two-dimensional arrays. I will pause here for a second to give people a moment to catch up with typing that out. Okay, that's a good question. We don't need to, you're not saying why, but why don't we need to define or name the data type of the second array? Okay. Oh, you've already got it, Limes, but let's look at it again. Remember, it's an array of a data type. So there is only one data type at the end of the day. In this case, it's integers. So every element gets an integer. So what we're saying is we have an array of ints. So there is always only one data type. And I should go back to my code so people can continue. I mean, this is just the starter code. So is everyone ready for me to start going? Can I make an array of images? Absolutely, you can. We don't have the building tools to store images in code, but you absolutely can. Maybe you could, but images. In fact, images themselves are just two-dimensional arrays of a struct that stores the red, green, blue value for every single pixel of a bitmap. So images, it's actually an interesting question. Images are actually two-dimensional arrays of structs. Because if you know the color value of every single pixel, then you get a bitmap. So yeah, you absolutely could. All right, we're ready to go. Okay, you see my code. All right, so first thing we want to do is create a two-dimensional array. So I think integers are the friendliest data type to do stuff with for the first time. So let's stick to an int 2D array. What am I going to name my array? Let's call it a grid. All right, let's call it a grid. Now we need two things, the size of the columns and the size of the rows. Best practice is to hash define, cols. We can say 5, hash define, that's not a hash, rows to be 5. So I get cols and I get rows. Put cols here, I can put rows here. That's it. A 2D array of ints, 5 by 5. So quick maths, you guys are engineering students mostly. How many elements will this data structure store? Well, damn. Was it rows and cols in the slides? It kind of doesn't matter. Maybe to be consistent, we can do rows and then cols, but I'll explain why it kind of doesn't. It just changes maybe the way you need to loop first, but we'll talk about that in a moment. Okay, you guys are coming at me on the row col thing. Yeah, you get 25 elements, 5 by 5. You just multiply the two. All right. So here we have some data. How do I get data into this thing, right? So I know it's named grid, but grid is not an array of integers, so I can't say like this. I can't do this, right? Why will this not work? Because grid at index I is not equal to an int. It's an array. Now, we know how to access an element at an array, don't we? If this is an array, I need to access an element, I need to use the same syntax. And this will assign 5 in the position 1, 1. So not the 0th element, but the first element, and not the 0th column, but the first column. So this is the syntax for accessing, and don't forget your semicolon, for accessing a particular random element in our grid. Oh, there's something else I forgot to talk about that's quite important. We still want to zero out our 2D grid array. So we still can do this, which is really cool. And we can actually still use this syntax to put data into a 2D array. But for now, we just want to zero this out. Okay? So this zeroes out. This puts some data in here. What I want to do next, I'm going to take a pause here. And we're going to come up, and we want, well, basically what we want next is we want to be able to print this grid. How do we do that? Okay, how do we do that? Now, I could put the code here, but we might need to print our grid all the time. So what should we do? You guys tell me. If I know I want to be able to print. So limes, you're jumping one step ahead. Nested loops is how we will access each array values systematically, but what could I do? Yes, alien got it first, quickly followed by Sinai. We want a function. We want a print grid function. It's a void function. Returns nothing. It just prints. So it's a procedure. It's called print grid. What's its data type of the parameter? What's its data type? Grid, can we get a bit more specific? What's the type, not the name? Not an integer. We don't want to pass it each integer one by one. Yeah, Paints has got it. We want to pass the array of the array. We want to pass the grid. But what's the data type of our grid? I mean, you can just look at line 19 there and steal it, basically. So not just one array, we still want that two-dimensional array. So whatever the data type of this grid is, which is an int named grid of rows and cols, Taylor's got it. We can just pass that here. And to be really nice, I'm going to call it to print, grid to print, just to differentiate it. Yeah, absolutely. A statically sized array, 5 by 5 of integers called grid to print. So when I call this function, print grid, and I pass it grid, right, this grid, it copies each value in the two-dimensional array to this variable. And now I get access here to grid to print, a 2D array of ints. Okay? This disconnect is really, really important. So you need to know if you've got a data type and a variable of that data type, and you want to pass it to a function to do something with it, you need to know the data type of the parameter. In this case, I wanted to pass the entire two-dimensional array, an array of integers with rows and cols, so that exact same type needs to go. Now, last question to you guys before we take a quick mid-lecture break. And this is something I really want to drill home, and I know people don't get their head around it for a little while. Is this grid the same as this grid to print? Yes or no? No, wild guess. Let's see what others think. So if you're saying no, I want you to type Y. So unlettered, 98. Wow, you got money, I guess. We are passing it in here. So line 23, we pass in grid. No, you guys are smartasses. Just puts Y. Y. So I am passing it in, and at this point, is it the same or is it a different variable, different value? Same value when passed in, but different. That's what Whale says. Yes, Y, yes, Y. No, because grid is not a global variable. Yeah, you're kind of on the right track. Yes, because we're passing it into the function. All right, so this is really, really important. You got to get your head around this. All right, listen. When you pass a value into a function in C, like we do right here, okay, it's a copy of the data. It's not the same data. So if I change grid here, this function does not see that change. This is a new array. This is a different array. This is a different variable in a different piece of memory. It's just that the values get copied in. Okay? Doesn't matter if it's an integer, an array, or whatever it might be. Okay? So the value would be the same at this point. The values are the same, but it's a different piece of memory, a different variable. So the answer was no. It's not the same thing. It's a copy of the data. The values are the same. It is not the same thing though. But yeah, lots of people take a while to get their head around that. Okay, let's go to lecture break. We'll come back, we'll do a quick Kahoot, and then we'll get going with the content. Okay, we're back. And you guys influenced me. I did make a little... Well, it wasn't a sandwich, it was a wrap, but you'll have to forgive me for my sins. Okay. Let's do a Kahoot 4.2 host live. Okay. All right, piling in. How many people do we have today? 130. That's fine. You can observe. Hopefully it's not a long one today. I don't want to spend too long on the Kahoot. I need to put the volume down a bit. Whoops. Cool. Okay. I'll give you guys a couple more minutes. All right, let's be nice in the chat. It's okay, we got a Kahoot that's going to come up and distract you all anyway. Alrighty. Shall we? Let's go. Oh, whoa. Whoa, 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 whoa. Go away. That was too big. Yes, agree, Brianna. Okay, question 1. True or false? C does not have a primitive string data type. We all hate double negatives, don't we? I know I do. Might move this up here. C does not have a primitive string data type. Yes, the answer is true, and most of you got it. It doesn't. There is no string X, right? You have to use int char. So we can make one, but we don't have one by default. Question 2. We're powering through this. What is the character used to end a string in C? Okay, we should all know this. You guys are string experts. You're right, Limes. You just got bit by the double negative. Classic. Classic. But what matters is that you knew the answer. Yeah, very good. Yeah, smashed it. Yeah, the null terminating character ends the sequence of characters within a string. All right, question 3. What is printed on line 4? These ones are always killers. Oh, this one's okay. Hello world. Ooh, there's this one. Okay, this one is maybe tricky. Yeah, 13. Good. Whew, I got it right. I was just counting with my fingers just there. Why is it 13? H-E-L-L-O, that's 5. 6 for the comma. 7 for the space. 8, 9, 10, 11, 12, 13. 13 for the exclamation mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. String length does not count the null terminating character. 13. We spoke about that at the end of last lecture. Remember, it counts a new line character if you hit enter on a fgets, but does not count it in a string length. Yeah. Yeah, I probably wrecked you guys yesterday after the lecture. Okay, that was a bit brutal. So it doesn't count the /O. Drake. Question 4. What is the exact output to terminal at the conclusion of this program? Let's take a look myself. Standard AO, string H. I should be quiet. Oh, this is a good question. Oh, I mean, too easy for you guys. This is a cool question because it demonstrates that strings are just character arrays. So we can loop through them the way we loop through anything, and we know that while the character at the particular index I, which gets incremented in the loop, is not the null terminating character, print the character. Okay? So we just print out exactly what's in the double quotes here. No, and we don't bring the null terminating character, but A, it can't be printed, and B, we're saying only loop while it's not the null terminating character. So while it is the terminating character, it won't print. Okay, yeah, Paints asks a good question. A few code examples don't have the length of the string here when it's being defined. What does that mean? What does it mean? Well, let me ask you this. If this was not a character array and this was an int array, and you had some numbers here with the curly braces, what would it be? It's just the size of this particular string. So we can do this sometimes when we're really lazy and we know we never need to reassign a larger string. So yeah, that's exactly right. This basically, not quite, but more or less is what fputs does. So it's not dynamic, Paints. It's not dynamic. It's static to the length of the string literal that it was assigned. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for the null terminating character. So this would be 14 characters long. So it is static though. It is static. We have no tools to do dynamic arrays just yet. Okay, what is the number of elements printed in array 4.5? Oh god, why are we doing 2Ds arrays? We just introduced them, but that's fine. We already spoke about how to do this. While you're answering that, what would the array values initialize be to if you wrote car string equals 0? So I think Liam, sorry, I'm answering Liam's question. That would just be like as if you did an empty quote, so it'd be just one null terminating character, I think. I'm going to need to be double checked on that. All right, you guys will smash this. You just multiply the two numbers, 4 by 5, 20. Easy. All right. How do you declare and initialize a 2D array in C? Okay, we just looked at this. Oh no, my water's out. Oh, I guess I should. Okay. Okay, you guys got done pretty hard here. I know we haven't actually looked at the syntax yet. Red is not correct. That is not how we assign values to it. This is not correct. We always do type, name, then the brackets. So this is correct, but we're not initializing it. Therefore, this is the answer. Which most of you did get, technically. You can absolutely have other data types here. We just mostly show ints for the introductory demos. And you can have three-dimensional arrays too. They're sometimes useful. All right. What is the syntax for declaring a string in C? This we know how to do. Yeah, very good. I'm not going to spend any time on that. Good job. Second last question. Multi-select. How do you access a specific character of a string in C? How do you access a specific character of a string? Are the kahoots actually worth joining? Is it fun or do you learn something? Guys! Well done. You could either do it by index or you could do it by memory address, which we've not spoken about yet. But really, they're one and the same. So either will get you the mark there. All right, last question. What's printed out on line 3? What is printed out on line 3? Yeah, absolutely 6. Why 6? Let's look. It was not the most popular answer. First is the rows, second are the cols. But the other way to think of it is the first size is the first thing. The second is the inner thing. So outer, inner, outer, inner. So outer 1, that means it's 0, 1. So it's this grouping, this array. Inner is 2. 0, 1, 2. So it's 6. And Sahil would have known that if he wasn't scrolling or she wasn't scrolling Reels and was doing the Kahoot. Called out. All right, who podiumed? Adorable Chicken. Good job. Bold Sloth. Good job. And top job goes to Bold Seal. So let me know who you are. Take a screenshot of your podium and you can come and get a Pokemon card if that so interests you after tomorrow's lecture. But we have 40 minutes left of this lecture. So celebrations out of the way and let's get back to what we need to get to. All right. Well done. Good job, Whale. Nice. Good to see. Okay. Get your celebrations out of the way. I want to finish this demo and then do something a bit more interesting. All right. We good to go? What have we got here? I've also forgotten to do something. We should forward declare our print function. Okay? Remember always to do that. All right. For now, let's do something. Let's put in a couple of other values here. To really... Oh, let's not do that. In fact, let's just do single digit numbers for a reason that will make sense later. So let's put some data in our 2D array. All right, just some random data. What will the rest of the values be? Obviously, we have 25 elements here, but I've only assigned 3 integers. What are the rest going to be? They're going to be zeros because we zeroed out our array first. So we zeroed out the array, we placed 3 random numbers in our grid, and then we passed it to print grid. So let's spend some time looking at print grid right now. Let's do that. All right. So we've passed in our 2-dimensional array of 5 by 5. This is a 25 element array. This is the job of this thing is to print it. So let's just say visualizing the 2D array. \n\n. Let's do that. Maybe I'll just do that. All right. what do we need to do here? This is the interesting part. Okay, we need to access each element of the grid, right? So if we had a 1D array, what would we use? I'm going to ask you that while I'm going to answer Ben's question. I thought we started 0 for initializing the grid, so it ends up being 36. Okay, no. Array sizes are the size. It's the length, not a 0-based index. Indices are 0-based. So here, these are 0-based. So we have 0 to 4, but that is still 5 elements. So 5 by 5, 25. But I see your confusion now. Okay, spot on. We would use a loop. So what we need to do here is use a nested loop. We've actually done this before. We've used we had a lecture on nested loops, except we just weren't tying them to a two-dimensional data structure like an array. Okay, so how do we do this? We have two options. I can say int I equals 0. No, I'm not going to do that. I can say int row equals 0, while row is less than rows. This row is being this one here. I might swap that. And I get the body of my loop. This will loop through each row. Maybe I'll put that there. Once we get to the row, we can loop through each col. How do we do that? We just do another loop. So I can say int col equals 0, while col is less than col. Oh my God, I'm so bad at this. I keep forgetting to increment. Okay. Oh, cols. In this inside point, we will loop through each row col. So I can do something like print my grid. Now, what am I printing? What am I actually printing every time I print? What am I printing? An integer. Well, that's excellent. Yeah, really good. We are printing an integer. We're printing an integer. Because why? We have a two-dimensional grid of integers, so we print an integer. Now, what's the particular integer that we are printing? It's going to be the grid to print at the particular row, at the particular col, where row and col is the integer that's being counted from 0 up. Now, I think I need to reset. Maybe I don't need to do that. And then here, I think I need to just printf a new line to start my actual next list of rows. So paint's fantastic. That's really good. All right. So let me just test this. I might have missed something with my so let's compile this into program. Did I make an error? I did not. Okay, look at that. So what's going on here? First, we zero out all our data. So by default, everything will be zeros. We put some data into a two-dimensional array. So the first row, sorry, the 1th row, so not the 0th row, which would be here, the first row, sorry, what am I doing? The first row and the first col, so first row, 0 row, 1 row, I can't do that, 0 col, 1 col, so this point we assigned it to 5, so we can see that there. 0, 4, so the first row, fourth col. Remember, these are 0 base, so it's -1. That's 1. Then we have 0, 1, 2, 3, 4. 0. That's 2. So we can see our data nicely placed. Isn't that cool? I think there's a little trick we can do here. % -4D to pad out grid a bit nicely. Yeah, maybe I can do 3 instead. Yeah, that looks good. That looks like a nice little grid. Yeah, that is loading up some data into a two-dimensional grid, passing the grid to a print function. Let's get rid of that. And then we visualize the 2D array. Let me scroll this down a bit. Do we have any questions on this? This is pretty cool. So Cyan's asking if I know, instead of forgetting to increment in the while loop, that I could use a for loop. So, you know, I do know that, Cyan. So I've been doing computer science for a very long time. We just stick to while loops to have a particular type of looping that we formally demonstrate. If you want to use a for loop, you can go for it. But it's an intentional design choice. You have to pick your battles sometimes. Cool. No questions. Lecture chat's gone quiet. Is everything okay? Are we getting our heads? Do we have our heads around this, or is it confusing us, or what's going on? Talk to me. All good. Does the function take the input int grid to print, or is that the output? Does the function take input into grid? So this is input. This is the parameter to the function. Okay. What are for loops? They're just ways to write counting while loops like we've been using them. They are a bit nicer because you don't need 2 separate lines, but they are syntactic sugar for a while loop. So you can use them, you can Google them, you don't necessarily need to use them. This works just fine. What if all the people who are struggling are too shy? Yeah, that's common. So sometimes the quiet people aren't the ones that are confident, but that's why you've got anonymous posts on the forum, or you can speak to your tutor and do things like that. I can only do so much. All right. Oops, I've lost my... let's go to slides. I'm stupid and proud. Good for you. Good for you. We did a visualization. All right. What I want to do for the last 25 minutes is a larger demo program of an array of structs. We can work towards some sort of project. I don't know that we'll get enough time to finish it. Something like battleships, something like noughts and crosses, some sort of game structure that uses 2D arrays of a struct. We can think about the type of program we actually want to build as we're building it. I want to get started with getting a basic structure of a 2-dimensional array of structs into the program. Okay? So that's what we're going to do for the rest of the lecture. No new slides, no new content. We are just going to do a bigger demo because it's helpful before the assignment. So let's call this a week 4 demo. All right. I'm going to do this. So we start a brand new program, fresh start. I know that I want to have 2D array of structs. Maybe someone can give me some ideas here. Or a room tour. Well, maybe we could do that. I like that, actually. I really like that. 2D array of structs with which are rooms. Is anyone playing that game? What's it called? Like Blue something? It was a Blue something where you go through the house. I only saw it. Something short on it. Yes, no, maybe. That's not what you meant. Oh, you want a room tour of my apartment, don't you? That's what you want. Yeah. So it goes two ways. Blueprints, yeah, that was it. Anyway, you're not getting a tour of my room. Okay, but I like the idea anyway, so thank you. Struct room. So a room, okay, what could a room have? A room could have, let's think about it. A room could have, maybe it could have a name? Oh, did you hear my neck crack? Would a room have a name? Does that make sense? Yeah, I think it does. So a room can have a name. A room can have a door, I suppose. Let me think about what we're actually building here. Let's just give it a name for now. Whoops, I'm really silly. I didn't give it a maximum length there. So it's got a name. What else might it have? A brightness. I'm thinking I want to make some sort of... We could do something like blueprints, I think. I don't know, maybe this is going to get too complicated, but okay. Guys, these demos, we don't know where they go. Sometimes they lead somewhere good, sometimes they don't. Deal with it. Deal with me. We'll try and do what we can do. Occupants is good, and it's a nice little integer. What I want to do, though, is I want it to have, it can have, look, could this just be, yeah, this could be, what if it's int left, int right, int, oh, let's not do that. Let's go west, north, south, east. So it's got these 4 integers. 0 is equal to blocked or a wall. 1 is equal to a door. This could be an enum, but for now this should work. Yeah, this would be for drawing the rooms around so you can get around. Not too sure if that's what I'll end up using, but so the room's got a name, it's got a number of occupants. Okay, and we have this. Let's say we can have 10 by 10 building, I suppose. So we have a struct room array called building, which is rows by cols. So this is what we wanted. This is creating a 2D array of a struct room. So a building is going to be 100 rooms. So this program will create 100 rooms. All right. What have we done here? God. We probably need... why don't we do this? We assign it to 0. We should let the user build the room. That's even better. Okay. Let the user build out 5 rooms. So maybe we always start at bottom center. And actually, why don't we change this to an odd number? Let's think about that. Is that right? Odd? Then we can have one in the middle. Yeah, that's right. Maybe we can make it smaller. 5 by 5. Ask the user for details and where the room leads. Okay, that would be pretty cool. It all gets set to 0, so these will be walls to start. That makes sense. Occupants will be 0. The name will be empty. So we need to first do. We'll need a loop while I is less than. We can just do 5 for now. So we'll ask for 5 rooms. So what do we have to ask? We need the user to build a room, which I think means we should have a function for a room builder. The room function needs to return a struct room, new room. Nothing gets passed in. We say struct room new underscore room, return new room. Okay, then we say new room. We got to let the user fill the details in. So we got to say printf create a new room. Printf how many occupants. So we want to scan f an integer into new room dot occupants. So we can just say scanf %d into new room dot occupants. So that does that. Then we want to say, what's its name? In fact, this one makes more, sense to do first. Now, we don't want to scanf here because room name is a string. So how do we scan a string into a string variable? You guys can't tune out and scroll reels. You got to stay with me. Ooh, Minesweeper would have been a good one. Don't distract me though, Limes. Okay, you're following along. Good. How do we scan a string from the user into a variable? String something I can't remember. He's honest. Scanf, not scanf. We don't use scanf for strings. Come on. How do we scan a string? fgets. Very good. We fgets into new room dot name. We give it the length of the room, like the maximum length of that string, which was this, and we get it from standard input. Very good. So this will read in the name into new room dot name. So it will assign it a name. Okay. Do we need a new library for... Oh, you're right. Thank you. We need to go string.h to get fgets. Good catch there. Paints. All right. What am I looking for here? Now we could let the user just tell us the room doors, but let me think about this for a second. We could also let the program decide it. I think let's let the program decide it. So this should just return that. I think that's fine then. So we return the new room here. Then we come down to main. In main, we zero this out. Okay, good. Always start at the bottom center. Okay, ask the user. So if we're going to start at the bottom center, what I think we need here is a current row variable, and it's going to be equal to rows minus 1. This is the bottom row. That should be rows minus 1, like that. Both would have worked. Int current col, and that can be equal to cols divide 2. Ints round to nearest floor, odd cols, so this works. But you might have to be careful if you change the size of your thing. So int row and int col will start at bottom row in the middle. So bottom center, that's what we wanted. All right, in I equals 0. I is less than 5. This will let us create 5 rooms. Maybe we'll say printf. Welcome to room builder. That's fine for now. Which direction would you like to go? Maybe we need to say printf. N is north, E is east, W is west, S is south. Don't forget your semicolons. All right, so the user's going to type in N, E, W, or S in this loop, and that will decide where we need to build the doors. Okay. So we can say car direction scanf %c space %c into direction. Scan the user's choice into a car. All right. We're only going to do this once, Ben, this loop, so I think it's fine to put it in main. All right. So if direction is equal to n, we can do something. Else, if direction is equal to north, we can do east. Oh, thank you. Good catch. Who was that? Sinai. Yeah, we need ampersand for scanning F into characters. Northeast, south, west. All right, so the user enters a character. We have we have a way to know which direction they want to go. If they want to go north, we need to say, we need to know, I think, let me think about this. We need to know the next room and the current one. I think that's correct. So we will also need, yeah, into next row. And int next col is equal to the current roll, which we'll need to modify in depending on the direction that they go. If they're going north, we're changing the row to be probably minus minus. We're going up a row. If I missed something, I'll check it. Actually, it's probably good to check this now. Yeah, you don't. Oh yeah. Thank you. I should probably compile this now, actually. DCC week 4 demo dash out to program. Make sure there's no major problem. There'll be some errors or warnings, I imagine, because we haven't used everything. Yep, we haven't used next call and we haven't used building yet. So that's fine. Good stuff. All right. So we're going north. So we know we need to go to, we know we want to be able to access the room that will connect to the north room. So we need to have the future row and col identifiers here. Let's not do out of bounds checking just yet. But let's just let them build the room. We can do create a room at that position, at the new position. So we can say the building, which is our two-dimensional struct, at next row and next col is equal to create new room, which the user will be asked to type in some details. Then we need to say the building at the current row and the current, col, so the current room, it's going to have a door pointing north. And then I suppose this one's going to have a door pointing south, is it? Yeah, that sounds right to me. We need a warning here. This is not validated. Could be an impossible room. We need to come back to that. All right. The other thing we're going to need is a print building function, but first let's see if this compiles. How long do I have? Oh no, 4 minutes. That's fine. Welcome to Room Builder, which we can go north. Create a new room. Okay. Oh, okay, something's wrong here. Create a new room. What's its name? Create a new room. What's its name? F gets into new room name. That looks okay. Why is it saying how many occupants straight away? Printf how many occupants? Oh, I might want, okay. But that shouldn't be the problem, is it? Maybe one of you guys can spot the problem. I go north. What's its name? Why do I need F get char before F gets? John Bree. The new line. Like I don't have a new line or I need a new line? it just scanning in the enter? But I'm not pressing enter. Oh, is it that enter? Maybe it's the enter from here. Will that work? This won't work, will it? Yeah, that's what I've just tried. Jake's room. 5. Okay, that might have worked. We can fix that up. Let's just assume that that sort of worked. I think we can get, if we can get a room builder, if we can get room print, a building print pretty quickly, then we'll see the beginning of something which we can continue next week. Print building. Okay, we need to print that. That's fine. Building to print would be something like that. John's going to look into what's going on. I'm going to go a bit fast here, I think. Probably going to make a mistake. Building layout. Oops, let's do it like that. Semicolon. Okay, while rows, row plus plus, col plus plus. For each element, let's print f. %C, I think we can do. Comma, building to print, bracket row, bracket col, dot north. So this will print the top wall, I think. Yeah, let's just print the top wall. Then I would need to print the others. We would need \n here. Okay, we're definitely not going to make this today, but we might get a start. Let's see what happens here. Oh, I should probably call it. So I build it here, and then I can call print building, return 0. That should get rid of this warning. Hopefully we get something. We should just see one door, I think, if we do build it with a north door. Yeah, my brain's liquid too. Okay, we're going north. I hit enter. Now it's asking me like Jake's bedroom. I hit enter. How many occupants? It's got 5. Let's just say I go north again. Okay, this can be Lime's room with 0 people in it. North again. I think we got to do this 5 times. I don't think we're printing the name anyway, so that doesn't matter. Let's do east. Oh no. Don't do that. Okay, maybe I'll just stick to north. North, Jake, 0, north, Jake, 0, north, Jake, 0, north, Jake, 0, Jake, 0. Oh no, something's broken. Print FC Ronald. Okay, why don't I do this? Why don't we do one loop? See if that works. we go north, Jake, we say there's 0 occupants. Okay, so I reckon there's something wrong with how the data is getting in. I'm going to have to look at it offline, but I'll document it and I'll fix it up, and then we'll continue looking at this. Yeah, we can continue looking at this after the week 5 lecture 1. How's that? All right. Anyway, we have a basic start here of a 2D array of structs with rows and cols. You can pass it around, do stuff with it. This needs a bit more time and debugging, but as always, and I know what the lecture feedback is going to be. Oh no, that's the wrong side. Yes, thank you, Bree. Bree has put the correct feedback form link. So give us some feedback on the lecture if you so desire to do that. I know the last demo was a bit rushed, but remember the point of today's lectures was 2D arrays. Enjoy the rest of your week. I will see you. I'll see you Monday. I will see you Monday. Remember to attend your week 5 labs next week if you can. If you can't, email the course account. Is there a particular reason we should do cols and then rows or vice versa? No, but you can do either. It just depends the order in which you loop first. So you could loop cols and then rows, and you could loop rows and then cols. Probably best to just pick one and go for it for the rest of term, I imagine. But sometimes you get a different starter code or something, and you need to be able to do it the other way. All right, I had a good time today. I hope you did too. Look after yourselves. I know you've got a lot of maths exams and other things like that spinning up, and things get a bit hectic. So take it one day at a time. Do what you need to do. Have fun. We want you to have a good time at UNSW. And I'll see you on Monday next week, week 5. Guys, we're already halfway, almost. All right, see ya.